Hey everybody, this is Mr. Munson, and we are in Unit 2, Geometry 2, however you want to say it, G.2, Logic and Reasoning. We're in concept number 4, which is writing a formal proof. And so a proof is where I can logically show you something is true through a series of logical statements. Now, back in the day when I was much younger, there was this fantastic movie called A Few Good Men. And Tom Cruise plays a military lawyer, and he's after this guy. And he's trying to prove to him he did some really bad stuff. And it's fantastic line, "You can't handle the truth." And so you might show this picture to your parents. I bet you they've seen this movie. If you haven't seen it, you might want to ask your parents if it's appropriate for you to see it. But it is a really good movie about logic and reasoning, where he makes a series of statements and proves that this guy has done some really bad stuff. Let's get started. So as we go through this video, we're going to review some basic terms and conditions and things like that that you have had in previous classes, okay? So basically, like for instance, this thing. Okay, so what this says is, look, if I take A and I multiply it times B plus C, the quantity B plus C, it's the same thing as if I just take A times B and B times C. We take the A and we distribute it through. The reason that this statement is true, that I can take the left side and change it to look like the right side, is the distributive property. All right, the next idea, property that I want you to know is this one. If I have something like A equals B, if I subtract a number from both sides, then I still have equality. This hasn't changed, doesn't become less than or equal to or something like that. It stays equal. If I started with an equation and I subtract from both sides, then I still have that they're equal. That's called the subtraction property, and you use that often when you're solving an equation. Sometimes you have a 3 on both sides or a 3 on one side, you want to get it off, and so you subtract 3 from both sides, and when you subtract 3 from both sides, right, it still stays equal. We don't have to change this sign in any way. All right, next property is this one. Suppose you have the statement, if A is equal to B, so I'm given A is equal. If I add C to both sides, it still stays equal. Nothing becomes bigger or smaller or anything like that. And of course, you know that one is the addition property. Okay, how about this one? Suppose I have A equals B, and I divide by C. Now, C can't equal 0 because we're not allowed to divide by C. But what would you call that thing, you think? Man, I hope this is becoming easy for you. That would be the division property. Okay, and then finally, the last one I want to show you is this one. You probably guessed it. If I have an A equals B, then if I multiply both sides by C, then it stays equal, right? Doesn't all of a sudden one side doesn't change and become bigger or anything like that. And that's called the multiplication property. Okay, so basically these properties are the things that allow me, if I have an equation and I decide I want to multiply both sides by a number, it stays equal. The multiplication property giving me the power to do that. All right, so let's take a look at this equation. So I'm given this equation, 3 times the quantity 4x plus 5 equals 45 plus 2x. And I'm asking you, prove to me that x equals 3. There's a couple ways I could do this. I could take x equals 3. I could take and replace it in the x in both sides. And so when I do that, 4 times 3, so if I put a 3 here, right? If 4 times 3 is 12. 12 plus 5 is 17. 17 times 3 is 51. Now I just went through the math of that in my head and spoke it out loud. So I want to plug in 3. Now let's plug 3 over here. So 3 times 2 is 6, plus 41 is 51. Okay? That's a way of proving x equals 3, and given this statement here in black. Okay? Okay, so what we're going to do is something a little bit different, and it's not an option. It's not like, well, that was really easy, I'm going to do it that way. We're learning how to write a two-column proof, and I'm taking you through a world that you're very familiar with, solving equations. And so what I want to do is I want to kind of introduce you to this two-column proof idea, how to write it and things like that, going through solving this equation. So what's going to happen is I'm going to write a statement over here on the left, and on the right, I'm going to write a reason why that statement is true. So the first statement I'm going to write is this one. And, if you look, it matches the statement given to me. Now, how do I know these two things are equal to each other? Well, the reason I know that they're equal to each other is because it was given to me as being equal. Okay? Hopefully that totally makes sense. Okay, so how about this one? How do I know that 12x plus 15 equals 45 plus 2x? Well, the reason I know that is because I can take that 3 and I can distribute it through, and when I do, I end up with these two terms. 3 times 4 is 12x, 3 times 5 is 15. There it is. Now, how do I know I can take this statement right here on the left and replace it with this other statement on the left? Why am I allowed to do that? And why has that not changed the whole entire equation? The reason is because the distribution property. If you look back at that statement that we just had, whoops, this basically said that if I had something that looked like that A times something, I could distribute it and replace it with the right side looking thing. And so that's all I did. I took that 3 and multiplied through and got the distributive property. Okay, usually the next step would be subtracting something. I'm going to start combining my x's on one side or whatever. Now, don't write this in here just yet. Okay, just watch for a second. I'm going to subtract 2x from both sides. And when I do, I get this statement. Now, how do I know that this stays equal? How do I know the left side is still equal to the right side? How come it doesn't like all of a sudden become bigger or smaller or whatever? Why does it maintain that equality? And it's because back in algebra, you learned if you subtract 2x from both sides, then it stays equal. That was known as the subtraction property. Okay, let's put an R on there, and that's to be understood later on, subtraction property. So usually, though, when we're writing these things that we're going to be doing called two-column proofs, we're not going to put that step in there. Some of you are going to really like the idea that we don't have to write our steps. But we're going to put that information after the reason of here. So basically in parentheses, I'm going to write minus 2x. Subtraction property says I can subtract something from both sides. The parentheses tells the reader who comes in late to the conversation what happened. I subtracted 2x from both sides. Okay, so here's my next statement. Do you think that's still true? 10x equals 30. Well, I subtracted 15 from both sides. That's pretty simple. Hopefully you're following my reasoning here. And if I divide both sides by 10, I get x equals 3. And there it is. I just proved that if that first statement to the left is true, which is given, then if that's true, then x equals 3 is true. All right. Now you know this as the law of syllogism as well as the law of detachment. I'm doing both things here. Okay? So I have this statement. If this is true, which it is because it's given, then this is true. And if this is true, then this one is true. And if this one is true, then this one is true. And if this one is true, then this one must be true. All right. Okay, now hopefully you followed my logic on that previous statement, series of statements. Seriously, if you did not, you need to go back and listen to it again and follow through. Basically, I did exactly what somebody would do if they were solving an equation, but I wrote the reasoning over on the right-hand side. Okay, now this is called a two-column proof, and it's going to look exactly like what we just did. So basically, I'm going to take what we did over there, and I'm just going to put some lines into this thing to help us make sure that it kind of has this formality to it, okay? So you'll be given a statement like this and say something is given, and then you're told to prove something, okay? So for an algebraic two-column proof, what you're going to do is always write the given in the first spot. and you're saying that that statement is true. Anything that's over on the left-hand side under statement, you're saying is true. But to say it, you have to have a reason to say it's true. And in this case, I can say that statement on the left is true because it's given to me. And when it's given to me, it's got to be given to me as being true. Okay, so then I'm going to say this statement is true. Now, why is that statement true? Well, as I said before, the distribution property. I'm allowed to take the left side, which is 3 times a quantity, and change it into just two things being added together by simply distributing the 3 through. I maintain that equality. It doesn't change it in any way. It's still a true statement. Okay, this is still a true statement. All right, next one. I'm going to say that 12x equals 30 plus 2x. Kind of changed it up a little bit. I did something, a step a little bit different. In this case, I subtracted 15 from both sides. Okay, so I write subtraction, and then in parentheses, I write what I did, right? Now, remember, you're not showing any work underneath here, and you're not drawing any lines. You're just simply saying statements. So if you leave this part out, I can't give you the points for it. So if you want to get points for doing this, you got to state the reason why or what you did in the subtraction property. In this case, we subtracted 15 from both sides. Next step, 10x equals 30. How did I do that? Well, I subtracted 2x from both sides. Then I got x equals 3, which is possible by division by 10 on both sides, right? Okay, once that statement, the last statement, once it matches what that statement is, the thing I'm trying to prove, I'm done. And logically, what's just happened is I said, hey, this is true because it's given. But if this is true, then this one is true. Why is that true? Distribution property. But if that one's true, then this one's true. Why? By the subtraction property. But if this is true, then this one must be true. Why? Because of the subtraction property. But if this one's true, then this one is true. And so I just proved to you that if this is true, then x must equal to 3. I just proved to you that that is true. All right, one of the things you'll have to do, that was an algebraic proof. This one's a geometric proof. So I'm given some shapes, a shape, some information, and I'm going to prove to the, whatever it is that they want me to prove. In this case, that angle SNO is equal to 72. Okay, so to go about doing this is I'm not solving equations anymore. I'm writing through a logical series of statements to show to you that SNO has to equal 72 given that those two other angles, 60 and the 58, are given. Okay, so the kind of the series of events that you're going to do on your do it problem is you're going to want to first of all identify what you know and put it into the drawing. So I know that this angle over here is 60 and this one's 58. Okay. And then they want me to prove that this angle right here is 72. So to get that, I need to start thinking, what do I need? You know what I need? I need to know that this angle right here is 72. That would be great. I would also, if I knew what these other two were somehow, then I could take that angle plus this unknown angle. I'm going to prove that it's 72. And I would check to see if those all add up to 180, right? But I don't know those angles. But I think I can get this angle right here by adding those two together, subtracting it from 180 to get this missing angle. Once I have this missing angle, then I know this angle through vertical angles. Okay? So when it says, what do I need? What I really need is that angle. If I could find that angle, then I could use vertical angles to find it. So I just told you my strategy. My strategy is this. I'm going to first of all identify that I've got these two angles. Then I'm going to use triangle sum theorem to find this missing angle. Once I find this missing angle, then I'm going to use vertical angles theorem to find that this one is 72. Okay, let's go ahead and walk through that together. Now, geometric proofs are where the brain really is going to be learning something new, and you're going to be struggling a little with this, and you need to understand that struggle. You might have followed through when I did that algebraic proof earlier, you might have fully understood that one. That's because you've been in the world of algebra for a long time. You're in the world of geometry now, and some of you will pick this up quickly, some of you won't. That's no problem. We want to keep on moving forward though. The way that you're going to come to know this is not by closing your eyes, not closing your ears, not putting down your head, but leaning forward and asking for help and getting extra help. And sometimes that's on an after school basis, maybe during class if we're working on this in class and you can ask questions on it. But we're not going to do 30 problems to make sure that you've got it. If you need 30 problems, cool. I want you to spend some time after school where you and I can work on this together and get you where you need to be. Having the whole class do 30 problems so they can understand this is very boring and tedious if they've already gotten it after 2 or 3. And it's no problem if it takes you 30. Don't ever see that as a down thing. Okay, so what's going to happen is I'm going to write a two-column proof. So the first thing I do is I write the word statement and reason. I put bars on it like this to create 2 columns. And then I put a 1 over here, and I usually put a 1 over here to match it. Okay? Then I take the given and I bring it from here down. Okay, so in this case, I've got the angle M is equal to 60 degrees. How do I know that's true? Because it's given. Now remember, I'm going to bring in those 2 angles into the proof. This is kind of like a story. I got to bring in pieces of the story, right? So statement number 2 is going to be the measure of angle 58 is true because that's given. All right, now I'm going to resize my picture here so I can get more of the 2-column proof in the screen. All right, line 3. Now remember, now that I know those 2 angles up above, I'm going to use the triangle sum theorem, 60 plus 58 plus that measure of MNU, this angle. I'm going to use that equation right there to get what that vertical angle is. So a triangle sum theorem allows me to write this equation, and that's the thing that gives me the power to say that that's true, that those 3 angles must add up to 180 degrees. All right, line 4. Well, the measure of MNU is 72. The way I got that was I basically subtracted 60 and 58 from the left side. And once I did that, I got, I took 180, subtracted 60 and 58 from it. And I got the measure of angle MNU is 72. Now that's not the angle they want to know. They want to know the other side. But man, I'm not close. I'm going to now say that the measure of SNO equals 72. And the reason? Because of vertical angles theorem. Okay? All right. So that's basically a 2-column proof for the geometric. If you're right now going, I didn't follow that, then your job, not everybody else's job, but your job is to go back in the video and watch and follow that reasoning again. Okay. Draw a line underneath that. Write the word summary. You might have gotten away from writing your summary. Go ahead and write a summary. Draw your line. Okay? Now on the next page is your do it problems. Remember, don't do your do it problems inside your video notes. Right now you should pause, open up your 3-ring binder, pull out some loose paper with the 3-hole punches in it, pull it out, put your name up the top right-hand corner with your block number and the date. We'll call this G.2.4, and then make sure you're writing in all of your information, right? You're copying all the information. You're not leaving it out and just giving me answers. I'm taking huge points from people who are doing that. And it's a shame because I think you understand it. You're just doing the cheap way out. It also looks a lot like other people's work where you just simply copy the answers and you're asking to get credit for their work. And I think that's a scam way of believing that you know how to do this. All right, so let me zoom in. And I'm going to talk a little bit about each problem and give you some hints. All right, number 1 is an algebraic proof. We did this one. This is a very simple one. This could just a couple of steps, okay? Now, number 2 is very similar to the one we just did with MUNS, that type of thing. So I want you to think through this one. You won't be able to do it super quick. This one's going to be quick. The one at top, 2x plus 5 equals 15. All right, so you're going to write 2-column proof for those 2. Make sure you write statement, reasoning, the bars, and all that stuff, okay? Problem number 3. It's just telling you to write in verbal. You're given this verbal statement down here. I want you to write it in your own uh, symbolic form, and then write the inverse, converse, contrapositive. Make sure that you maybe write the word original for the original statement, and then the inverse, converse, and then the contrapositive, and then just write your answer next to it. Okay? All right, and then number 4, write an equation to solve for x and y. We've done a problem like this in the warm-up. So you're going to have to write 2 equations, okay? Do your work separately. Have your x work over here, let's say, and your y work. Make sure you're answering the questions. It's asking you to find the measure of these, so you have to show the work. You can't just show me the answer. You got to show plugging it in and all that stuff. All right, that is it. I hope you have a fantastic time. That's been a long video, almost 20 minutes. But I think you're going to see that this is going to pay off. We're going to be dealing with this for a long time. All right, very good. Have a great evening.